I'm back. I'm front.
Am I going sideways again?
Yes, sir.
There we go.
Unit vocabulario, learning target.
Number two.
I will understand the specialized vocabulary of the atomic periodic table unit.
And be able to take my quiz. We wrap it though.
Yeah. Maybe less retakes this time, please.
How about before 2 weeks out of through the unit is up?
Yeah.
That'd be nice.
Let's kick it.
Well, here's a little picture of ionization energy. Doesn't mean much to us because we don't know what that ionization energy is. Tells us who has more and who doesn't.
Those are the trends of them. But
yes,
this is the energy required to remove the first valence electron. Like if this was a valence electron, how hard I got to pull to remove the first one off of that atom. Every atom is slightly different in terms of their pull for their valence electrons.
Yep.
So there's a different number.
And there's a trend for electronegativity. And electronegativity is almost how much I want to hold on.
Right. Or technically, it's my attraction for his electrons. So how bad I want to pull on these versus how hard he's holding on to them. It's tug of war.
Yeah. It'll become apparent.
All right. The atomic radius is the distance between the middle of the nucleus and the end of the atom.
Valence shell.
But more importantly, what does it tell us? Just in general terms, what does it tell us?
If you put two of them together, that would be your bond length.
Sure.
Is that what you're looking for?
And
no.
Simpler. How big
Simpler.
atoms is.
Yeah.
Sure.
It really is because the radius.
You're too smart, you know.
Sorry.
Yeah. Because we're not going to get into bond length or bond angles or none of that stuff. Used to.
Yep.
Used to.
Not anymore.
Used to. No more shapes. No more nothing. But you know. Ooh.
Ionic radius. I love
picture.
this chart because it shows you both the atomic radius and the ionic radius.
All right,
and it's the radius of an ion. Simply put, does it get bigger or smaller when it loses or gains electrons? That particular element.
In
And that's what you
relation
got to
to
know.
its parent element, right? Yeah. Chemical reactivity. So here's a little graph that talks about metal and non-metal reactivity, where the most reactive metals and non-metals are. And this is the behavior of an element based on its number of valence electrons and the number of total number of shells.
Yep. And there's lots of things go into that, but it's basically behavior of elements, like Milk said.
That's really it.
Right. Metallic character. How much like a metal is that element? You'll know if it's a metal if it wants to lose its electrons. It has luster, conducts electricity, and is also ductile and malleable.
Yeah. Those
Great
are
words.
4 of the major
Testable words. No.
metals.
For sure.
Characteristics of metals.
Non-metallic. Well, if we know what metals are, the opposite is non-metal. So its ability of an electron to attract electrons, they're dull or brittle in this case. They don't conduct electricity very well or heat very well at all. It's a completely different class of elements. If you had all the elements on the table, you'd look at some and be like, wow, these are similar but different. And those are similar but totally different than those. Metals and non-metals. That's just kind of how it breaks down.
True that. And so here's that picture of some common metals we all know.
Yep.
And by definition, metals, they're elements that lose electrons, again, have luster, conduct electricity, they're ductile and malleable, and they are found to the left of the staircase. Now, I see metallic character and I see metals. Heads up, both of those definitions are pretty close.
Yep.
Your job, figure out which one goes with which so you don't get them messed up on the quiz. They are close.
Metals are found to the left of the staircase on our periodic table.
Sure, and character is how they react.
Correct.
Metalloids. These are the elements that are found on the staircase. So they have a mix of metal and non-metal properties. That's about it.
Yeah, the only one that touches the staircase that's not a metalloid is aluminum.
And we all know that that's a metal. We've held that.
It's just got so many metallic properties that we can't call it something that it's not. Non-metals. These are in the right-hand side of the periodic table. There you go, the yellow ones in that picture. They attract electrons. They're dull, not conductive, brittle if they're solids. Oftentimes they're gases, and you find them on the right-hand side of the periodic table. Like the periodic table has a dividing line. It's the staircase.
Yeah.
The left is metals, the right is non-metals, and some of the ones that touch the staircase are the metalloids.
Let's show them what that staircase is since we got it right here.
Yeah.
Check it. See that bold line right there?
The
You see
thickness. It's a staircase. Boom. That's the dividing line.
Yep. So alkali metals. This is going to be group 1 metals. As you see, there's a list of them.
It's the stack.
Yep. So there's group 1 metals. They all have 1 valence electron. Note Hydrogen is not a metal, technically not part of this group.
Right.
Okay, although it is group 1.
Alkaline earth metals are the next group. It's group 2. They have 2 valence electrons. The way I remember the difference between alkali and alkaline earth is that alkali has 1 word, so it's group 1, and alkaline earth has 2 words, so it's group 2.
Cool.
Easy.
Helps.
Easy peasy. Halogens, group 17. So we're actually going to skip the whole middle for the time being and go all the way over to the non-metal group. There it is. These are group 17 elements. They have 7 valence electrons and want 1 electron to complete their outer shell, and therefore they're very reactive.
Super mad reactive. And just the opposite is to be said of these noble gases, group 18 right there. This is all the group 18 elements. They have 8 valence electrons, which means they have a full shell. They are very unreactive. Note HE is the only one with 2, but he can only have 2.
Yep.
They are very snooty, the royals. They don't like to mess around with us peasants.
Yes.
So they're not very reactive at all.
There you go.
Next up are the transition metals. Those are the ones that are found in the middle of the periodic table, groups 3 through 12.
Mm-hmm.
They don't follow the same rules with the valence electrons that the rest do. But when they bond together, they form colored solutions.
Mm-hmm. Yeah, which is neat.
Mad waiting.
And that is testable, actually.
for sure.
I've seen it a ton.
The periodic law. This is when physical and chemical properties of elements become predictable when they're arranged by atomic number. So as I said before in a previous video, we chemists can look at the periodic table and see where an element is and predict how it's going to react with other elements and its properties, because that is the law of how the periodic table is set up.
Periodic is something that comes every so often.
And it repeats.
The newspaper comes every day, and ESPN magazine comes every month, and it gets very predictable, and that means the same thing.
Periodic table is very predictable because of the
Yes.
periodic law.
You got it. Periods. This is going across.
Boom, 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 boom. 7
Nice.
periods. They're labeled on our reference
This is
tables.
across the reference table, and it is the same as the number of energy levels. Just so we're
One energy level, 2, 3, 4, 5,
It's
6,
even
7.
labeled periods.
Yep.
So it helps. Okay.
If you go up and down, those are your groups and families. They all have the same number of valence electrons in them.
Again, these are labeled on our reference table.
Right, and this is specifically the 4 families that we named.
Yep. Now, I love my diatomic elements. I call it Hofbrinkel.
Yep.
There are 7 elements that have diatomic packages when they're found in nature. Hydrogen, oxygen, fluorine, bromine, chlorine, iodine, and chlorine. I said that twice.
You did.
Iodine and Cl.
Chlorine.
Nitrogen. I forgot nitrogen.
Nitrogen.
Yeah. So anyways, there's 7 of them. You remember them in order, you'll get them in order.
Got it. Hofbrinkel's the way I remember it too. I used to always like to fantasize that Hofbrinkel's what Einstein named his dog.
Yeah.
Carbon. Here's some allotropes. These things are all made out of carbon, by the way.
So the
Diamonds and graphite in your pencil made out of the same stuff.
they're the
Isn't that
same,
weird,
but different.
but different.
Yeah.
So these are substances of the same element, but with different physical chemical properties because of different arrangement atoms. Example, graphite and diamond, they're both made of carbon.
Exactly. You pack things differently. They react
Oh, check
differently.
it.
That's right. We did good job.
So you study Pesh quiz.
Absolutely. Okay. Toodles. I pushed the button. I stopped the video.